Good morning, boys and girls. I would like to show you another math game, just using a deck of cards. This time it involves multiplication, and students in grades 3 through 6 can play. I've already removed the face cards to Jack, the Queen, and the King, as well as the Jokers. The deck should be shuffled and dealt out. I am just going to cut them in half to save time. So if we had two players, let's say third graders, who are learning their multiplication facts, they each have half a deck, and they each turn over one card at a time. The first person to find the product of the two numbers takes the cards. In this case, 90. Again, each person turns over a card at the same time. The first person to figure out the product, in this case 24, takes the cards. Another variation is to have each person turn over their cards, but this time they turn over two. They figure out their own multiplication fact. In this case, 8 times 4 is 32. 6 times 3 is 18. The person with the higher amount can take the cards, or if you wanted to, the person with the lower amount could take the cards. So there are some simple ways to practice your multiplication facts. Next, I would like to show you some ways and variations of the same game. Let's say you have a strong understanding of your multiplication facts from 1 to 9. You can add in to the deck of cards the Jack, the Queen, the King, and the Joker. Make the Jack worth a value of 11. The Queen can be worth 12, the King could be 13, and the Joker could be 14. And play the games the same way if you'd like. You can either turn over one card each and figure it out. In this case, we have a Queen worth 12 and a King worth 13. Or you could turn over two cards each. In this case, I have a Queen worth 12 and a 6. 12 times 6. Let me think about that for a minute. What do I know? Well, I know 12 is really 10 plus 2. We learned that back in first grade, right? And we know how to decompose numbers. So if I take 10 and multiply it by 6, we know what people like to tell us is add a 0 to the 6 and make it 60. We're not really adding a 0, are we, ladies and gentlemen? No. What we're doing is multiplying by a power of 10. And we know 10 times 6 is 60. We also know 6 times 2, which is 12. So the answer must be 60 plus 12, which is 72. And I know with practice, ladies and gentlemen, you can do this in your head. Let's try again. The other person in my imaginary game has a King and a 7. So that's 13 times 7. What do we know about 13? How can we decompose a 13? Well, a 13 is a 10 and a 3, right? We know 10 times 7 is 70, and we know 3 times 7 is 21. 70 plus 21, well, 70 plus 20 is 90, plus one more makes 91. So in this game, the person with the King and the 7 would take the pile. Maybe you'd like to work on fractions. Again, using a deck of cards, split them in half. The Jack could be worth 11, the Queen worth 12, the King worth 13. If you want to use a Joker, you can make that 14. The first card you turn over will be the denominator, and the second card you turn over will be the numerator. Let's look at an example. In this example, I turned over an ace, that's worth 1, right? So that's our denominator. And the second card I turned over was a 2. So we have 2 over 1, or 2 firsts. As we know, we can look at this in many ways. 2 over 1, 2 divided by 1. How many 1s can fit into 2? No matter how you look at it, the answer is 2 wholes. 2 over 1 represents 2 wholes. The other person in the imaginary game I'm playing turned over a queen, which in our case is worth 12, and it's the denominator. The denominator is 12. And the numerator, in this case, the second card I turned over, was a 6. So we have 6 twelfths. What do we know about the relationship between 6 and 12? Well, hopefully you understand that 6 is half of 12, or that 12 is double 6. So really, what we're saying here is 6 twelfths is the same as, or if we simplified it, it would be 1/2. So this person has a half. This person has 2. If we're playing whoever has higher wins, this person would take the cards and add it to their pile. One last variation of these card games would be Decimal War. Again, you take your deck of cards, but this time you need to remove your face cards and your jokers. You can turn over 2 cards, 3 cards, or more, depending. Let's start with a simple example. I'm going to turn over 2 cards. In this example, the first card you turn over is the whole number. This is a 7. The second card you turn over is the card that represents the tenths. So what do we have here? We have 7 and 2 tenths. Remember, we don't say 7.2. Point is not really a math word in this context. We do use the word point in geometry. But this is 7 and 2 tenths. My imaginary friend has turned over a 7 and 8 tenths. If you're playing who has the larger number, obviously 8 tenths is more than 2 tenths. We don't look at the whole number because they both started with 7. And we know 8 tenths is larger than 2 tenths by 6 tenths. The game could continue and you can add more and more cards. If you turned over 3 cards, the first card is the whole number, 7. Second card's the tenths, 2 tenths. And the third card would be hundredths. So how do we say this number? Well, we say 7 and 26 hundredths, right? You say the number as you see it, and then you determine the decimal place. That's last, and you say the number out loud. So again, we have 7 and 26 hundredths. My opponent, who's imaginary today, turned over a 7, an 8, and a 4. So this person has 7 and 84 hundredths. 84 hundredths is larger than 26 hundredths, therefore they would take the cards. I hope you enjoyed this. Again, it's very simple to use. All you need is a deck of cards. Thank you, boys and girls. Have a fantastic day.